Hi everyone, in today's video we're going to be going through the chain rule, which is a rule we're going to need when we're finding the derivative of the composition of two or more functions. So just to kind of take a step back, when I say composition, we're going to have functions that look like this, f of g of x. And so what we're going to be doing today is taking the derivatives of these functions. So I'm going to use the notation the derivative with respect to x of our composition of functions. Now, I'm going to be using a lot of color today to help us walk through this. So the big idea here is we're going to take the derivative of the outside function We're going to take the derivative of that first, and then we're going to take the derivative of the inside function. So we work our way from the outside in. So for example, in this setup, we're going to take the derivative. Now, in this case, my outside function is f, and then my inner function is g of x. And so what we'll do here is go through some problems to make sure we all really get how this works. So we're going to be finding the first derivative of the following functions. So what I always like to do first is I'm going to do a little color coding here to kind of help me see what that inner and outer function is. Woo. The zoom is a little crazy here. Sorry about that. Hold on. Okay, we'll just go back here. So for number one, we have our function f of x. Now, my outer function is going to be all of this to the fourth power. So something to the fourth power. And my inner function is x squared plus 3x. Notice I still have f of x. I haven't differentiated yet, so the notation is still f of x. Now in the next step, when I take the derivative, we're going to be finding f prime of x. So the first thing we're going to do is take the derivative of the outer function. My outer function is something to the fourth power. So I'm going to have 4. The stuff inside is going to stay the same for right now. So x squared plus 3x. And now just like when I'm doing the power rule, I brought the exponent down. My inside stays the same, and now I have to subtract the exponent by 1. So far I just differentiated that outside function. Now I go and I'm going to differentiate the inside function, which for us is going to be 2x plus 3. So now I've dealt with all of the pieces of that function. So I can do a little bit of simplification. We're not going to worry too much about it, but since it's pretty easy here, I'm going to distribute this 4 to the 2x plus 3. So I'm going to have 8x plus 12, and then this factor is just going to stay the same, x squared plus 3x to the third power. And that would be our derivative. All right, let's look at number 2. Now the first thing I'm going to do here is change this radical to a rational exponent. So I know this is the same as 4x squared plus 5 to the 1/2. So this example is going to be really similar to number 1, except now our exponent is just a fraction. So again, I'm going to rewrite this, and I'm going to use color to show the outer function, which is everything to the 1/2. And my inner function is 4x squared plus 5. So chain rule tells me for y prime, I'm going to deal with the outer part first. So 1/2 times all the stuff on the inside. I subtract 1 from the exponent, so this becomes the negative 1/2. Now, kind of what I like to call the guts, the insides all stayed the same. Now in the second step, when I'm dealing with the inner function, now I'm going to take the derivative here, which is just going to give me 8x. So now I've taken care of all the differentiation. I'm just going to go ahead and simplify. I can do 1/2 times 8 will give me 4x, And then I have times 4x squared plus 5 to the negative 1/2. Now, since this had a radical in the answer, I'm going to rewrite this with a radical. So now my 4x is going to stay up top. To make this a positive 1/2, I would move it down to the denominator, and I'm going to write that as a radical. So 4x over the square root of 4x squared plus 5. It would be my final answer. All right. For number 3, we have our function g of t. Again, I'm going to rewrite this as 3 times 6x plus 7 to the 1/2 plus 4x to the 5th. Now I'll put some color in here. I have g of t equals, this is just a constant, so I'm going to leave it out front. I have all of this to the 1/2. My inner function is 6x plus 7. And now this is just a totally separate term, so I'm just going to leave that. That's going to be an easy one to deal with because that's just our basic power rule. All right, so now we're going to differentiate. To start off, I know that the derivative of this is just going to be my constant times the derivative of my function. So again, I'm going to deal with the outside by bringing down that exponent. All that inside stuff is going to stay the same. I'm going to subtract 1 from my exponent. And again, all this stayed the same for right now. Now, before I move on to my next term, I need to take the derivative of the inside. In this case, that derivative of this whole expression is just going to be 6. And now I can just add the derivative of my second term, which is going to give me 20x to the 4th power. And so we can go ahead and simplify g prime of t. Let's see. I have 3 over 2 times 6, which is just going to give me 9, if I did that correctly. 9 times 6x plus 7 to the negative 1/2 plus 20x to the 4th. And again, if I wanted to rewrite this, this would be equivalent to 9 over the square root of 6x plus 7 and then plus 20x to the 4th. Oops, can't see that down there. There we go. And that's my final derivative. All right, now number 4 is pretty complex here. We have a lot going on. So let's go ahead and break this down and figure out kind of what's our outside and what's the inside. Now, first of all, I'm going to take all of this and rewrite it. So negative 3x cubed plus 4 quantity squared minus 2, and this is all to the 1/5 power. So when I start to look at this, my outside function here is going to be everything here raised to the 1/5 power. Now, my next function is this squared minus 2. And then all the way inside, then I have my negative 3x cubed plus 4. So you can actually see I've got 3 layers going on here. But again, the idea is that we work from the outside in. So I'm going to draw a line here and scooch as far over as I can because I'm going to need some room. All right, so first things first, we're going to deal with our outside. So I'm going to use my power rule. I have 1/5. I'm going to leave myself a bunch of room. If I subtract 1, that's the same as subtracting 5/5. So I'm going to have negative 4/5. So that took care of the very outside. Now, all of the insides right now remain the same. Okay, so I dealt with my blue. Now we have to go to the green. And so we're multiplying by the derivative. Now here, I know that I have power rule again. So I would bring this coefficient down. I'm going to leave the insides all the same. And if I subtracted 1 from that exponent, I would just have a 1 here. And this minus 2, its derivative is just going to be 0, so that goes away. Inside, I still have my negative 3x cubed plus 4. And now the last piece is to differentiate the very inside. So I have times a negative 9x squared. The plus 4, its derivative is 0. So I'm done. So I've differentiated everything, and now I'm just going to see what I can simplify. So it looks like I have a 1/5, and I have my 2 and my negative 9. So this derivative is going to be negative 18 over 5. I can take the x squared, and then really everything else is just going to stay in parentheses as it is. So negative 3x cubed plus 4 quantity squared minus 2 all to the negative 4/5 power. And then I have to account for this factor, my negative 3x cubed plus 4, and I already have my x squared up front. Now for this one, we won't worry about that negative exponent. I just want to make sure at this point that we've accounted for all of the chains that we need in our answer. All right. On the next page, we're just going to look at some example problems that use tables. Now, not all of these will be chain rule, but these are really common types of questions that you'll see on the AP exam, so we want to make sure we have some practice with these. So, in our table, we have values of f, f prime, g, and g prime, and we're going to use that table to evaluate these derivatives. So for number 1, they're telling us that h of x is the sum of f of x and g of x, and we're asked to find h prime of 2. Now, before I jump into the specific value, I'm just going to write an equation for h prime of x. I know that h prime of x is just going to be the derivative of f plus the derivative of g. So now h prime of 2 is just f prime of 2 plus g prime of 2. And I'm going to use the tables to find those values. So I'm going to look in the f prime column. F prime, when x equals 2, is 1/2. G prime, when x equals 2, is 1. So I have 1/2 plus 1, which is going to give me 3/2. For our next one, we have h of x equals the difference of f of x and g of x. So my derivative, h prime of x, is just going to be f prime of x minus g prime of x. So now we'll substitute 2 to have h prime of 2 equals f prime of 2 minus g prime of 2. We can use the table again. F prime of 2 we said was 1/2. G prime of 2 was 2. Whoops, no it's not. It's 1. So 1/2 minus 1 gives us a negative 1/2. All right, now here's where we start to see chain rule. Right? I know that h of x is equal to the compositions of the functions f and g. So it's f of g of x. So if we want to think about using color here, we know that our outside function is f, and our inside function is g. So if I want the derivative, I want h prime of x, we know that we take the derivative of the outside first. So f prime, we said our inside stays the same, and then we multiply by the derivative of the inside. So now I know that h prime of x is equal to, let's use color here, or excuse me, not h prime of x, I want to look at 2. It's equal to f prime of g of 2 times g prime of 2, and now we're all set up and we can use that table. So I have to evaluate the inside first before I know what I've got here. So I've got f prime of, let's see, let's go to the table for g of 2 is going to give us 2. So f prime of 2 times, if I go back to the table, g prime when x equals 2 is 1. So now I just need the value for f prime of 2, which gives me 1/2. So 1/2 times 1 equals 1/2. All right, last one for today here. Again, we have a little bit of chain rule going on. So we have h of x equals, now in this case our outer function is everything squared. Our inner function is f of x. So when we take the derivative, we're going to take the derivative of the outside. So 2 times everything. If I subtract 1 from 2, I just get 1. My inside still stays the same. And then I multiply by the derivative of the inside, which is just f prime of x. So now I want to find h prime of 2. So I have 2 times f of 2 times f prime of 2. So let's see. 2 times f of 2, we're going to grab from the table. So f of x when x equals 2 is just 1. So 2 times 1 times f prime of 2. So f prime when x equals 2 is 1/2. And then we get an answer of 1. All right, so that's what you need to know for the chain rule right now. As usual, when we're back in class, you'll be doing some practice on this to make sure we all get the mechanics of how this rule works. Thanks for watching.